Good day, students. My name is Mr. Benibo Briggs from Sleek Engineers International School. I'm a maths teacher. I hope you're staying safe at home and keeping to all the COVID-19 guidelines as stated by the Nigeria Center for Disease Control. Today, we'll be talking about the topic mensuration of solid shapes. Mensuration of solid shapes, prisms, and cones. And for this lesson, our objectives are, by the end of this lesson, you should be able to state the formulae for the volume and surface area of a cube, a cuboid, and a cylinder. Also, you should be able to apply the different formulae stated above given in problem solving. Okay? But for now, this will be our first video on this topic, and we'll be dealing with prisms alone. We'll begin with prisms. In our next video, we'll go on to cones. A prism is a solid which has a uniform cross-section. A prism is a solid which has a uniform cross-section, and we have examples of prisms. Our examples of prisms, we have cubes, we have cuboids, we have cylinders. And those are the three we'll be working on for today's class. Okay, so we'll just jump right into the class. We have the general formulae for the volume of prisms. The general formula for the volume of prisms, how we derive the formula we use in getting the volume of prisms. Okay? Here I said the volume of a prism is giving us the area of the uniform cross-section multiplied by the perpendicular height of the prism. Another formula I've given here is the area of the base of the prism multiplied by its height. So you can actually use either formula to be able to derive the volume of a prism. Okay, so we'll just jump right in. Our first prism we're looking at right now is a cube. A cube has its base as a square. The cube has its base as a square, and we know for a square its four sides are equal. If its four sides are equal, that's why you see here from the diagram you have here, you have L representing the length, L here representing the width, and L also here representing the height. That tells you that all of its sides are equal. So if the base is a square, we already know that the area of a square is its length times its width. So if you multiply L by L, it gives you L squared. L times L gives you L squared. And based on our formula here giving us volume of a prism, we said the area of the base multiplied by its height. Since the base of the cube is a square and the height of the cube is L, length is L, breadth is L. So if you multiply the three of them, area L times L, L squared, multiplied by the height L gives us L cubed. We have, once again, the length L, the breadth L, and the height L. If you multiply the three of them, the length multiplied by the breadth multiplied by the height, L times L times L, gives us our volume as L cubed, as followed by this formula, area of base multiplied by the height. Okay, now I have SA here, which represents the surface area of a cube. When we talk about the surface area of a cube, we are talking about the area of all the surfaces of the cube. Looking at this cube, a cube has 6 surfaces. A cube has 6 surfaces, and I tried as much as I could to represent the 6 of them here. You have the top, the bottom, the left side, the right side, the front, and the back. That gives us 6 different squares. And as I said previously, that the area of a square is its length times its breadth, L times L, which gives us L squared. So if this front face has an area of L squared, the back has an area of L squared, the top has an area of L squared, the bottom has an area of L squared, the left side an area of L squared, finally the right side an area of L squared. We add L squared into 6 different places. So if you have L squared plus L squared plus L squared plus L squared plus L squared, finally plus L squared in 6 different places, it gives you 6L squared. That is how we get the surface area of a cube, because we are adding the areas of all of each sides, each 6 sides. Now we move on to a cuboid. Now, a cuboid has its base as a square. A cuboid, once again, has its base as a square. But sometimes you could also find cuboids that have their bases as rectangles. Now, the most important thing, as I said, the volume of a prism is the area of its base multiplied by its height. The area of its base multiplied by its height. In our cuboid here, we have the length, we have the breadth, and we have the height. So for us to get the area of the base, it has to be the length multiplied by the breadth. And the height is represented by h. That's why we have a volume of a cuboid as the length multiplied by the breadth multiplied by the height. That's why we have LBH. I repeat, we have the length multiplied by the breadth and finally multiplied by the height of the cuboid. That's why we have the volume as LBH. Now looking at the surface area, SA represents the surface area of a cuboid. Now looking at this, we have this top and this bottom. So if this distance from here to here is L and from here to here is B, it is the same thing as what we have up here. The top and the bottom have similar cross section. So the area of the top will be the length times its breadth, which is L times B, which gives us LB. And if the area of the bottom is L times B, it also means that the area of the top is L times B. And right now we're talking about the surface area of the cuboid. So this is part of the surface area of the cuboid, which is the top. The bottom is also part of the surface area of the cuboid. So if the area of the bottom is LB, and the area of the top is also LB, LB plus LB gives us 2LB. That's why we have 2 here into LB. Now we go to the next one. If you look at this face, it shows us we have a height h here, from here to here. The height from here to here is the same height from here to here, the same height from here to here. So it means that this length here is represented by h. So if we're looking at this front face, the area of this front face is given to us by the length multiplied by the height. The area of this front face is given to us by the length multiplied by the height. If you look at this back face represented here, it's the same cross section as that of the front. So the area also of the back face is its length multiplied by the height, which gives us LH. So if we combine the both of them, the area of the front face added to the area of the back face, that gives us LH plus LH. That gives us 2LH. That's what we have here. So I'll just scribble this down. We already have 2LB plus 2LH. Now we'll go to the last one. The area of this face on the side will be the breadth multiplied by the height. On this right side, the breadth multiplied by the height. So if we look at this right side, the area of this right side will be the breadth times the height, B times H. And if you also look, the cross section we have on the right side is exactly the same cross section we have on the left side. So it means that the area of this left side is also B, the breadth, times H, which is the height. So if we add the both of them, BH plus BH gives us 2BH. Talking about the surface area of the cuboid. Remember, we said the surface area of the cuboid is the addition of all the areas of all the sides. So we first did LB. We have 2LB here. We did the other one, 2LH, and finally 2BH. Now if you look at the three of them, you notice that something is common. We can factorize. 2 is common to the three of them. So if we factorize, we have 2 into LB plus LH plus BH. That is where we got this formula from. That is how we're able to derive this formula. Okay? Now we move on to the cylinder. Now the cylinder has a rounded top and a rounded bottom and its height. Now the rounded top has the form of a circle. The rounded bottom also has the form of a circle. Now if you look at it, the circle we have at the bottom of the cylinder is the same thing as the circle we have at the top of the cylinder. The circle we have at the bottom is the same thing as the circle we have at the top. Now from the bottom of the cylinder to the top of the cylinder, we have what we call the height h of the cylinder. From the bottom of the cylinder to the top of the cylinder, we have what we call h, the height of the cylinder. Okay, how do we derive the formula for the volume of a cylinder? Remember what I said earlier, that the volume of a prism is the area of its base multiplied by its height. Now, looking at a cylinder, the base of a cylinder is in form of a circle. So we ask ourselves what we already know. What is the area of a circle? The area of a circle is pi r squared. The area of a circle is pi r squared. So following this formula, the area of the base, which is the area of the circle, which is pi r squared, multiplied by the height of the cylinder, which is h, gives us pi r squared h. That is why we have the volume of the cylinder there as pi r squared h. Okay, we're done with that. Now, we have to talk about the surface area of the cylinder. Okay, so now we are able to find the formula for the volume of a cylinder. We move on next to the surface area of a cylinder. Now, a cylinder has its curved surface area and also has the surface areas of the bottom and the top of the cylinder. So for us to be able to find the total surface area of a cylinder, we first have to find the curved surface area of a cylinder. Now I said the curved surface area of a cylinder here, I said the formula is 2 pi RH. How did I get that? Now if you look at the bottom and the top, they are both circles, okay? So the perimeter of a circle, or which is the circumference of a circle, is 2 pi r multiplied by the height of the cylinder. That's what gives us 2 pi r h as the formula for the curved surface area of a cylinder. Okay? Also, if you look at the bottom and the top, the area of the bottom circle is pi r squared. The area of the top circle is also pi r squared. When you add pi r squared to pi r squared, it gives you 2 pi r squared. So the formula for the total surface area of a cylinder is 2 pi r squared added to the formula for the curved surface area, which is 2 pi r h. If you look at it, you factorize it because 2 pi r is common to both sides. If you bring out 2 pi r, we're left with r plus h. So the formula for the total surface area of a cylinder is 2 pi r brackets open r plus h brackets closed. Okay, now that we have been able to get this formula, we can now try to apply them in problem solving. I'll move on to our first example. We have a wooden block here, a representation of a wooden block. The question says, calculate the volume of the wooden block above. All dimensions are in centimeters. Once again, it says calculate the volume of the wooden block above. All dimensions are in centimeters. Now if you look here, we have a block, okay? We have this cross section as its base, and we have this length as its height. Remember, I told you something, that when we want to find the volume of a prism, we multiply the area of its base by its height. Now if you look at this diagram here, taking this cross section as its base and this other cross section as its height. Okay, so if this figure here is the base of our wooden block, we ask ourselves, what does this figure look like? The representation of this figure is the representation of a trapezium. Clearly looking at this, PQRS is the shape of a trapezium. Okay? And if you look at it very well, it has two parallel sides. This line is parallel to this. So the lines PQ and the lines SR are both parallel to each other. Okay? Now, we know that for us to be able to find the volume of the wooden block, we have to be able to find the area of the base. And formula for area of a trapezium is half the sum of its parallel sides multiplied by the height. The parallel sides are PQ and SR. Okay? So the length of PQ is 3 plus 4, which is 7 centimeters, plus the other one, SR, which is 4 centimeters. Now multiply by the height. QR is the height of this trapezium, but the length of QR isn't given to us in the question, so we have to be able to find the length QR. Now we ask ourselves, how do we find the length QR? Once again, looking at this, since it is a trapezium and the lines PQ and SR are parallel, since these two lines are parallel, it means that the length from here to here, which is Q to R, is the same thing as the length from S, a perpendicular line drawn, to this point. If you draw a perpendicular line straight down from the line SR at point S down to the line PQ at this point B, it gives you a perpendicular line, and it means that this length QR is same as the length BS. So how do we find the length BS? I know I had previously taught you about Pythagorean triples. We have a triangle now, PBS. We have triangle PBS. The length of PB is given to us as 3 centimeters. The length of PS is given to us as 5 centimeters. And obviously, since we have the right angle here, it means that the line PS is the hypotenuse of this particular triangle. Now, what we are left with is the length BS. So using Pythagoras rule, okay, we have PS squared is equal to PB squared plus BS all squared. Now the length of the line PS is 5 centimeters, so we have 5 squared is equal to PB, which is 3 squared, plus BS, which we don't know, we're looking for BS all squared. Now 5 squared gives us 25, 3 squared gives us 9, plus BS all squared. So if we rearrange this, okay, and collect like terms, we should have BS all squared will be 25 minus 9. When you take 9 to the left hand side of the equation, or you subtract 9 from both sides of the equation. Okay, 25 minus 9 should give us 16. So we have BS all squared is equal to 16. Now for us to be able to find BS, we have to divide both sides of the equation. We have to take the square roots of both sides. For us to be able to find BS, we have to take the square roots of both sides. So taking the square root of both sides. We have the square root of bs all square is equal to the square root of 16. So the square root of bs all square will be bs will be equal to plus or minus 4 centimeters. But since we are looking for the positive value, then bs will be equal to 4 centimeters. Okay, so we have been able to find the length of the line bs. Since bs is also equal to qr, it means that the length of the line QR is equal to 4 centimeters. Now we can comfortably find the area of the trapezium PQRS. So area of PQRS, according to the formula here, is half sum of the parallel sides multiplied by QR, which is 4. Okay, so 2 here 1, 2 here 2, we have 11 multiplied by 2, which gives us 22 centimeter square. That is the area of the trapezium PQRS. Okay, so since we have been able to find the area of the base of the wooden block, the next thing is to find the volume of the block. As I said earlier, the volume of a prism is represented by the area of the base multiplied by its height. Okay, so since we have the area of the base as 22 cm squared, we have volume of block which is equal to the area of the base, which is 22 cm squared, multiplied by its height, which is 12 centimeters. And that gives us an answer of 264 centimeter cube. This is the volume of the block. 264 cm cube is the volume of the block. Now we move on to the next example. Now example 2. A rectangular tank is 76 centimeters long, 50 centimeters wide, and 40 centimeters high. How many liters of water can it hold? Okay, so I've been able to make a representation of the rectangular tank that was talked about in the question. It says it's 76 centimeters long, 50 centimeters wide, and 40 centimeters high. So this is our representation of a rectangular tank. When it says how many liters does it hold, it means that we're talking about the volume of water it can hold inside of it. Okay, since this has a rectangular base and a height, it means this is a cuboid. Okay, so volume of tank, we'll be using the formula for the volume of the cuboid, which is the length multiplied by the breadth multiplied by the height. So the length is 76 centimeters multiplied by the breadth, which is 50 centimeters, okay, multiplied by its height, which is 40 centimeters. If we multiply the three of them, it gives us a total of 152,000 centimeter cube. That is the volume of the tank V. But in our question, it says how many liters of water can it hold? So they want the volume in liters. So we have to convert from centimeter cube to liters. And as we already know, 1 liter is equal to 1,000 centimeter cube. So therefore, our volume of tank V will be equal to 152,000 cm cube, all divided by 1,000 cm cube to give us liters. This 0 cancels this cancels this cancels this, and we're left with our final answer. The volume of the tank is equal to 152 liters of water. That tells us that this particular tank can hold a maximum of 852 liters of water. Now we're moving on to the third example. Now moving on to example 3. Calculate in terms of pi the total surface area of a solid cylinder of radius 3 centimeters and height 4 centimeters. Again, calculate in terms of pi the total surface area of a solid cylinder of radius 3 centimeters and height 4 centimeters. Now you have to take cognizance of the fact that the question says in terms of pi. So you are not expected to use the value 22/7 or 3.142 to replace pi. So the first step in the solution is to always make a representation of what is said in the question. So I tried here to make a representation of a cylinder of radius 3 centimeters and height 4 centimeters. Question says we calculate in terms of pi the total surface area. Remember, this is a cylinder, and I had previously given a formula for the total surface area of a cylinder. I said the formula for the total surface area of a cylinder is 2 pi r into r plus h. Okay, so if we impute the values of r, the radius, and h, which is the height, into this formula, we have the total surface area of this cylinder as 2 multiplied by pi multiplied by our r, which is 3 centimeters, okay, into our r, which is 3 centimeters, plus the height, which is 4 centimeters. Now 3 plus 4 gives us 7, so we have 2 times pi times 3 centimeters multiplied by 7 centimeters. Okay, so 2 times 3 gives us 6, 6 times 7 gives us 42. Centimeter multiplied by centimeter gives us centimeter square. So our final answer as a total surface area of the cylinder is 42 pi centimeter cube. This is why they said you should give the answer in terms of pi. So the representation of pi must be there in the final answer. Okay, thank you for listening. We'll now move on to your assignments for this particular class. First question says 2.5 liters of oil are poured into a container whose cross section is a square of side 12.5 centimeters. How deep is the oil in the container? I repeat, 2.5 liters of oil are poured into a container whose cross section is a square of side 12.5 centimeters. How deep is the oil in the container? The second one says a measuring cylinder of radius 3 centimeters contains water to a height of 49 centimeters. If this water is poured into a similar cylinder of radius 7 centimeters, what will be the height of the water column? Both questions are very simple. All you need to do is take your time, sit down, think, and you'll be able to come up with what is required of you in the questions. Once again, my phone number is 0806 361 0526. You can reach me on WhatsApp through this number, or you can send your answer to my email address askbenny247@gmail.com. So, thank you once again for listening to me. Have a nice time at home. God bless you.